Emma Custer of the South Central Cask, and she's going to talk about projected changes in climate.
Yes, thanks, John. So is everybody seeing that screen correctly? Look good on your end? Okay, perfect. All right, so as John mentioned, I'm going to talk a little bit about kind of past, but also future climate projections. And so I'm gathering a lot of this from the latest National Climate Assessment. I just want to talk through some of that. But we're glad that you're here today to kick off our virtual classroom series in this Sagebrush and Climate Change training series. As John mentioned, my name's Emma Custer, and I'm one of the members helping to lead this series. And I was also involved in the Grasslands one last time. I'm the University Assistant Director at the South Central Cask, or Climate Adaptation Science Center. And today I'm going to be talking about this topic. And bear with me because I'm also losing my voice. So if I start going scratchy at one point, I apologize for that. First, I want to start by making sure that we all know the difference between weather and climate. These two terms are often used interchangeably, but they refer to very different timescales. So weather refers to our current state of the atmosphere. It's when we wake up in the morning and we decide if we need an umbrella or a sweater. We're going to look at the weather. Climate, on the other hand, is the statistical collection of weather conditions at a specific place over 30 years or longer. So in essence, climate's what you expect, maybe like our personality, but weather is what you're going to get. So maybe our current mood. Okay, now that we have that cleared up, hopefully, let's do a little mini lesson on the greenhouse gas effect so that we can understand why our climate is changing. So Earth has an energy budget that's the balance of incoming and outgoing radiation. I'm not going to dive into super detail here, but just wanted to give you a little snippet. And this kind of forms our greenhouse effect. So the greenhouse effect is naturally occurring and life-sustaining. And if we didn't have it, we would be a very cold, desolate planet. But, however, increases in greenhouse gases alter how much of that outgoing radiation is ultimately released back out to space. And so, as we have more greenhouse gases in the atmosphere, that blanket, kind of denoted by the thicker red on the right-hand graphic, is getting thicker and thicker. So if you pile on a bunch of blankets, what's that going to do to you? You're going to get warmer. That's what's happening to our Earth. So here I'm just showing the atmospheric carbon dioxide concentration that's been measured at Mauna Loa since just before 1960. And as you can see, there is a steady increase in carbon dioxide over time. And I want to do a little just kind of Menti poll. We're going to hope this works. So if you hop over to the Menti question, we're going to create a word cloud real quick about what we think this means for our weather and climate. It can be like a word, it can be a small phrase, kind of whatever you're thinking. And I'm going to hop over to the Menti cloud. I think I have to stop sharing this and share the Menti cloud. Oh, is it working? So you can join at menti.com on your computer or on your phone and then use that code. It looks like we've got some responses: unpredictable, increasing, unstable is a good word. I see a theme with warming. Chaos. Extremes, yeah. I'll spend maybe just like 30 more seconds here. Fire, good word. Oh, shifting, that's a good word too. All right, well, thanks for joining in on that, and feel free to keep adding your words. I'm gonna stop share, go back to the other presentation. Is there anybody who would like to just briefly maybe come off mute and talk a little bit about the word or words that they chose? There were lots of warmers.
I can.
Go for it. Thank you.
I chose chaos simply because things are becoming erratic. Unpredictable would have been okay too, but I liked chaos, climate chaos. So just because it's all over the place right now. And depending upon what region of the world or country that you live in, we're having different types of catastrophes. So
That's great, Yvette. Thank you.
Yeah.
Anyone else like to share? All right, guess we have a quiet group this morning. That's okay. All right, we'll move on now. Thanks for sharing. Appreciate that and your responses. So now that we've talked a little bit about kind of our own expectations or experiences with climate change, let's see what the current observations and future projections show for the Western US. All right, so the Western US has already seen an increase in annual average temperatures by 1.5 to 2.5 degrees Fahrenheit. And the darker the red on the graphic, the warmer those temperatures have become. And so you can already see that temperatures have changed in the winter and summer months as well. That's the kind of lower two parts of the graphic. And then if we look at annual precipitation on the right-hand side, we also see that it's generally decreased across much of the area as well, especially again during the summer season, as denoted by the brown in the bottom image. As like everything else when it comes to climate change, the impacts are not all uniform, and the changes depend upon the season and location that you're at. When we look at observed changes in extreme temperatures, we see that the Western US has seen a decrease in the number of cold days. So that's days when temperatures stay below 32 degrees, and then an increase in the number of hot days and warm nights. So in general, what this graphic is showing is things have gotten warmer, which, yeah, you guys have already picked that up in the word cloud. And when we look at trends in extreme precipitation, we see an increase, especially in the southwest, in total precipitation on the heaviest 1% of days. So meaning that heavy rainfall is continuing to get heavier. We also see a slight increase in the 5-year maximum daily precipitation and annual maximum daily precipitation across the Western US. Despite the overall drying trend that's been observed, and we saw in the other graphic across the Southwest and much of the West, extreme precipitation events have increased. So again, these are things that have already been happening. So what does that all mean? It means that climate change is not a future problem, right? It's a now problem. And our recent changing temperature and precipitation patterns are already impacting our ecosystems and the things that we care about. So we've seen things like declines in mountain snowpack. We've seen things like greater proportion of our winter precipitation falling as rain. We see receding glaciers, decreases in stream flow, biodiversity loss, wildfire conditions. And this is just a small snippet of things. But I want to go back to the Menti poll for a minute and have you say how many of these that you've already kind of experienced or dealt with in your own management area. So I'm going to go share that Menti poll again. Had some people experience quite a few, it looks like.
Emma, there's a request in the chat to either show the impacts again, or maybe just restate them so people can
Oh,
remind
yeah,
them.
sure.
what we're talking about.
I'll just quickly run through them. So we had declines in mountain snowpack, a greater proportion of winter precipitation falling as rain, receding glaciers and rising elevation of snow lines, decreases in stream flow, increasing frequency and intensity of drought conditions, biodiversity loss and ecosystem transformations, and increasing wildfire conditions. And thanks, John. I can't see the chat when I'm in screen share mode. All right, looks like some folks are kind of wrapping up on this. Is there anybody who would like to share some of those impacts that you're already seeing on the land? Some of y'all said 5+. One volunteer, come on.
We are certainly seeing decreasing snow and earlier spring snowmelt down here in northern Arizona where I am. And I apologize for my camera. It seems to keep turning off.
No worries. And thanks, David. I see you're posting in the chat. Yeah, if you want to post in the chat too. So we see the flashy spring snow melt, hotter, larger wildfires, the bad kind. Yeah. Definitely seeing lots and lots with fires. It's great. Not great. Sorry, that's bad. Wildfires are not great. All right. Well, thanks everybody for indulging me a little bit on the Menti poll. I know it's a little early in the morning for some of y'all on the western side of the US. I'm already at 11, so I'm kicking. All right, we'll continue on. So now that we know things are changing, let's explore how it might continue to change in the future. So when we look at future climate projections of temperature, we see that the northern and western parts of the US are likely to experience proportionally greater warming compared to the rest of the nation. Climate scientists expect that temperatures across the western US will increase by 3 to 10 degrees Fahrenheit by the end of the century. That's depending upon which trajectory we take. So the graphic here shows 4 plausible yet different pathways for our future, and the actions that we take today matter. So the top left shows projected temperatures associated with 2.7 degrees Fahrenheit of that global warming, while the bottom right goes all the way up to 7.2 degrees of global warming. So when I say those numbers of global warming, it doesn't mean that every place uniformly gets that high, but these are the impacts that we see across the US when we reach that kind of level globally. And so one of the largest takeaways here is that even if we drastically reduce our emissions today, we're still locked into some amount of change. We have to be talking about adaptation, which is what this training series is about. And when we look at extreme heat, we'll continue to see a decline in the number of cold days for the Western US and an increase in the number of hot days and warm nights. So again, it's just continuing to get warmer. But that does not mean that cold days won't happen. It just means they'll be less likely to happen. And then with precipitation, we see that climate scientists expect precipitation to increase by up to 15% in the Northwest US and decrease by up to 10% in the Southwest, again, depending upon that trajectory we end up on. For the Northwest in particular, precipitation is expected to increase in the winter months, but decrease in the summer months. We also generally expect to see less snowfall, resulting in reduced snowpack and decreased spring runoff across the region. And And then looking at extreme precipitation, we do see an expected increase in the kind of number of extreme precipitation events, and that's kind of shown throughout this graphic as well. If we look at the graphic, the darker shades of green, darker shades of green correspond to a greater increase in the amount of precipitation on the heaviest 1% of days, 5-year maximum daily precipitation, and the annual maximum daily precipitation. So extremes just get more extreme. And this part of the reason why extreme precipitation is such a big deal for the Western US is because of these things called atmospheric rivers. So atmospheric rivers are these long, narrow bands of water vapor in our atmosphere, and they're associated with extreme precipitation. Climate scientists project that a greater number of strong atmospheric rivers will happen as we have more climate change, and they're also going to reach further inland. And this is really not surprising given that warmer air can hold more moisture. So as our atmosphere is warming, it's holding on to that moisture, it's getting more and more moisture, and then it's coming and dumping it on the Western US. And then we have things like compound events. So as we plan for the future, we must also consider these compound events, which result from the occurrence of multiple climate drivers or hazards that, when combined, have greater impacts to ecosystems and communities than isolated hazards do. The graphic shown here shows compounding events that happened between 2020 and 2021 on both the West and East Coast. And I'm going to focus on the top part in the red where it's the West Coast. As one example, because of ongoing severe drought and extreme heat in the 2020 and 2021, we saw significant wildfires in the region, and they were very destructive and had a lot of impact on the land. And then we saw an atmospheric river come in that caused flooding and mudslides in recently burned and drought-affected areas. So these types of compounding events, whether they happen at the same time or just near each other in such a way that a system can't respond very well, is going to be problematic. And these are expected to become, again, more frequent with continued climate change. Okay, so getting close to the end here, now that we've explored some of the changes that we expect to see with temperature precipitation, I wanted to highlight the three key messages of the most recent National Climate Assessment in the Ecosystems chapter. The first key message highlights that climate change is driving rapid ecosystem transformations. And I wanted to point out the Sagebrush system, given that that's the focus of this training series. And according to the NCA, and I'm assuming all of you have seen this as well, there's a growing distribution and abundance of non-native and highly flammable cheatgrass occurring in sagebrush systems. And moving forward, it's expected to see that we'll see a lengthening of the wildfire season as well, because drought frequency, duration, and intensity is going to continue to increase. So that's just going to make the system more and more vulnerable. The second key message is that species changes and biodiversity loss are accelerating with climate change. So we've seen many plant and animal species shifting to higher elevations or more northern latitudes, and expanding ranges for some and shrinking ranges for others based on the adaptability of that species. Within all of these changes, some resource managers are starting to look for things called climate refugia, which are locations where environmental conditions are changing more slowly than the surrounding areas, and trying to figure out, what can we do to help those spaces. And the last key message I want to talk a little bit about is the impacts to ecosystem services. That here there's an opportunity for risk, there's risk and there's opportunities. So long as, I need to take a minute. My voice is going. All right, sorry, y'all. Bear with me for just a little bit longer. So I wanted to talk a little bit about some of those risks and opportunities. When we think about recreation, rising temperatures can extend seasonal recreational activities in some areas, so long as it doesn't become too hot. If it becomes too hot, then the opposite's going to happen. Another example of this is with ecosystem-based adaptation to help increase community resilience to climate change, and that's through the use of ecosystems. And then as we wrap up this talk, I just want to remind everybody that future trends on ecosystem use and benefits are not always clear, but there are perhaps some opportunities that are worth exploring. And we can do that through things like adaptation and transformation planning frameworks. So this is in, again, the National Climate Assessment. These frameworks, they'll be explored kind of throughout this whole training series. And as we go into the workshop later, for those that will be attending the workshop, you'll get a deep dive into these frameworks. But I just wanted to highlight them briefly here and talk about how these types of frameworks can help resource managers make climate-informed decisions. And also that it's an iterative process, right? So as we're thinking about climate change and the management decisions we're making today, what decisions we make today may have to change, right? Because the future is not set in stone. We don't know what the future is going to hold. So we may try to resist some things now, that then we'll accept some things later, then we'll direct some things, then we'll resist some things. But it's not a one-time thing, and it's not a one-size-fits-all solution. So this is challenging work, and I just want to thank you all for being here today, for doing this type of work. And I'm excited to see where the rest of this session and also the rest of our training series goes.